phenolphthalein in it. And I'm going to drop in a piece of sodium. Okay? So this is how one way you can describe this. A piece of sodium is dropped into water. Right? So how are you going to represent the sodium? Sodium ions or elemental sodium? Element. So you're going to have sodium, and you're going to react that with water. Okay? So we do this. We drop this in. Okay?
Whoa.
And we get a little smoke, a little fire. The sodium's floating around on top. And it turns magenta. So what are you making? What's one thing you know that you're making?
Hydroxide.
How do you know you're making hydroxide? You made phenolphthalein, right? Okay? So you know with that phenolphthalein that being added in there, as soon as that turned magenta color, you know that one of your byproducts was hydroxide. Okay? Now, if you look at what could potentially happen to this reaction, now that you know about redox, is sodium going to lose electrons or gain electrons?
Lose.
It's going to lose. So something has to take it in, right? So one option is that it could bind with the oxygen. So one option out of this, because oxygen has a charge of 2 minus, right? Okay. So one option is that the sodium comes in, kicks out the hydrogen. That would explain the smoke and the bubbles. Okay. And you could make hydrogen gas and NaO. You'd have to make that as Na2O. Okay. That's an option. Okay. Not. Are you just on a struggle bus or what?
You know what
I should read it. I should read it. Just give me a second.
You know why I don't teach freshmen?
Why?
Because they struggle with stapling.
It's hard. It's hard.
Do you want me to come over and do that?
Watch this, banger.
He's like, it's staple. Well,
Wait.
slam it, Mike.
There we go.
Bang, bang. 6 times the goal.
Hey, hold your applause. Hold your applause.
Okay. So why can you just look at that beaker and know this did not happen?
Because it doesn't seem right.
Let's just use
There's
the.
So
no
what?
hydroxide.
There's no hydroxide.
There's no hydroxide. Okay? This seems logical. Oh, the sodium comes along. It's going to give up the electrons. It's going to react with the oxygen. We're going to make Na2O. That would be soluble because all group 1s are soluble. And you would generate hydrogen gas. But we know this didn't happen. And we know it didn't happen because it turned basic. So this is a situation where we can't see the movements of the electrons, but we see the net effect of what happened. So as soon as that thing turned basic, we knew something had to produce hydroxide. We also know sodium really likes to give up its electron. So here's another option. Perhaps it only kicks out one of the hydrogens, and you make sodium hydroxide and hydrogen gas. Now, does that seem to match with our observations? Yes. Because now, is sodium hydroxide going to make it precipitate?
No.
No. Why?
It's group one.
It's group 1, right? Now, balanced?
No.
Horribly not balanced. What are you going to do to balance it?
We need some coefficient multiplication.
Multiplication then. So, what's we going to multiply now? What are we doing? Jamaican math?
thinking I said no to the accident.
No, I can't do it all.
Good job, McCann.
You smoking your ganja? All right, so come on.
Fire. NaOH by 2, Na by 2, H2O by 2. Ooh, that's not right. Oh, and then that might be right.
That is right. That is right.
Everybody can wait for that.
Son, speak up.
Son, you got it.
The moment was lost. I don't
No,
know.
son.
There's a
you
moment.
know-
There's
son,
a new moment.
There's a
now.
new moment.
There's another moment.
You know what it is, son.
Tell me you
And
all are
H2O
not
by
happy
2. I
with
said
this.
the H2O by 2.
Now we're cool?
I'm not okay with
Probably
it.
not, but
I'm not okay with it.
close.
Hold
Why?
on. Let me look at it. Holy shit.
How do they teach you to balance equations that make sense?
No, those are all
I
balanced.
like that.
Yes, it's balanced.
Yeah.
Okay.
I said that the first time.
Okay, now I'm going to take water, a little more phenolphthalein, and now I'm going to drop in a piece of calcium.
Nothing's gonna happen.
Now, what do you think's going to happen?
Nothing.
Nothing. Why?
Salt water.
Calcium.
Your answer is salt water? Nothing's going to happen. Why? Salt
I thought
water.
we were talking about like NaCl.
I'm gonna drop a chunk of elemental calcium into water.
You know what? I think it's going to become acidic.
You think it's gonna become acidic?
Yeah. Now let me explain.
Speak. I want to hear this.
I had it and I forgot it, but I'm just telling you it's acidic.
Why?
Just like at some point we're
Okay, no.
we're gonna get
Step back, Jack. Step back, Jack.
Calcium hydroxide.
So, if it's going to be acidic, what has to be kicked out?
We just need hydronium.
You just need something has to kick out this.
Yeah.
Okay? So something has to take. You can think of this as being H in an OH group. So something has to kick that out.
Yeah, basically. So calcium hydroxide is hydronium.
Okay?
Yeah.
So you would make calcium hydroxide, which is a strong base,
Yeah.
right?
Yeah. But hydronium.
But then, and if you put H plus in there, you'd have hydroxides and hydronium ions.
Oh. Problematic.
Well, not really.
Oh.
What do you get when you react hydronium ions back with those hydroxides?
Water.
So you're just going to make nothing but calcium water.
Like
Yeah.
water.
Salt water.
Salt water.
Hey,
Okay.
okay. On the right path.
Let's just put this in. Okay? See what happens.
No.
That's this one.
Not
slower.
It's just
That was
Well, I'll give it time.
It's slower.
You know, if you drink,
I
can't
Same reaction,
I
but
don't
slower.
see
Then
anything.
Oh, it's because of milk.
Well, you're very much generating some magenta color.
Oh, it is.
Okay?
It's the same reaction, but slower.
Now, the sodium floated. Calcium sinks. It's denser. Okay? It's denser than water, right?
Oh, there it goes.
Wow.
So now we're cranked up. So we're generating a tremendous amount, and actually it's buoyant because it has so many bubbles on it. Okay? Right? So we've got a very, very vigorous reaction, and notice that these two are the same color. So no matter what it produces,
Oh my gosh, it's gonna explode.
okay?
Oh my God, something happened.
Oh my God.
It's just making a lot of whatever the gas is.
Hydrogen.
Now,
Oh, no, that's
Can you light it? Can you light the gas?
no, it's so diffused so fast. And so here's the story. So what do you get out of this?
Hydrogen gas.
So are you producing hydroxide?
Yes.
Yeah.
So the same thing is happening. So the calcium here, are you making calcium oxide and hydrogen gas?
No.
No,
How do you know?
because there needs to be an OH.
There needs to be an OH somewhere. So it's the same idea. The calcium or the sodium, if you think of water being a hydrogen and an OH group, it doesn't have the capacity to kick out both hydrogens. It displaces one of them. Now, and you know what's going to happen. This is why when you look on this chart, okay? So if you look at calcium and magnesium, okay, they're way down here at the bottom as the elemental form. So you have, in this situation, this is actually going to be reacting with water. So if you look at water, and down here with where you have water, okay? So technically what's happening here is that this isn't hydrogen. So if you look down here, you have water, H2O. Gaining 2 electrons turning into hydrogen and OH. So notice down here you have calcium down here, and you also have sodium, which are below them. So if you put calcium, or in this case sodium, anything below water, this isn't hydrogen. You're not reacting with hydrogen. You're reacting with water. Now, I take for example, a quarter coated with silver. I drop that in water. What's going to happen?
Nothing.
Nothing.
You can wish.
Nothing. Why?
Because.
Because
Where's silver in relation to water?
it's way above.
Way above. So what's going to happen?
Nothing.
Nothing. This is why we use silver. This is why we use copper. This is why we use gold in jewelry, because they don't react with water. Certainly react with water. It's like, oh, here's this nice gold necklace. Just don't take a shower with it. Or if it did, this is what would take place. Okay, which would be bad. Okay, so stop you on the camera.